All right, this puts us in, I think it's the fourth section of the chapter on rational functions. And what a nightmare. Fractions inside fractions. Ah! So one piece of advice takes care of all of these cases, and it's a very sensible piece of advice. So you got fractions inside fractions. See this one big division sign. So this is the big numerator, this whole thing here. Big numerator, big denominator, because it's a big fraction. This little fraction has its own little numerator and denominator. So when you are thinking about these things, think big denominator, little denominators, think the extra adjective so you're saying the right stuff and you have an idea what's going on. Because you don't want to just go at it with no idea like a weasel. So let's see what we can do. What do we have to do so that this whole mess turns into a single fraction with a single numerator and a single denominator? Well, you got to get a common denominator in the big numerator and a common denominator in the big denominator. So I'm going to do that with you right now. Well, the big numerator, the common denominator has to be x to the third because you got to cover all three denominators. Well, x to the third takes care of that. X to the third would cover that. X to the third would cover that. So this guy needs x squared over x squared. This guy needs just x over x. This guy's already got the x cubed. So the upstairs has a 4x squared plus an x, it's a minus because of that minus sign, minus x, and then plus 3, all over x cubed. So that's one fraction. It's still the numerator. The big numerator now is one fraction. That's an improvement. Now down here, I just need to multiply this guy by x over x because I spot the x squared. This guy needs one more, x over x. So I now have a 2x minus 5 all over x squared. Now what do you do when you have a fraction divided by a fraction? You flip the second fraction and multiply. So this thing is equal to, and I just copy that top fraction over. I don't change it. 4x squared minus x plus 3 all over x cubed. And it's times x squared over 2x minus 5. All right. I can cancel an x squared out of that x cubed because they're in position to cancel like that. Can I cancel a 2 with that 4? No, because this 4 isn't times everything. This 2 isn't times everything. So I can't cancel with a big division symbol unless the thing that I'm canceling is connected by multiplication to everything. Well, this x cubed is connected to the entire denominator by multiplication. This x squared is connected to the entire numerator by multiplication. So this x squared can cancel, leaving a 1 and leaving just an x. So the final version is just that. 4x squared minus x plus 3 all over x times 2x minus 5. Is there any chance that this 2x minus 5 will cancel into this quadratic? No, because look, yeah, maybe the 2x could factor, maybe this thing could factor into 2x times plus or minus something, but this is just a 3. I'm never going to get a 5 up here. So it's not even worth factoring. There's nothing to cancel out. So you stop there. This is the kind of stuff they expect you to be able to do. Now the next step is, suppose you have a big mess, fractions inside fractions, and it's an equation. In other words, it's equal to something, and you have to solve for x. So we're going to do one of those. Took a problem out of the book, and it's a weird one. So here's what it is. Here's the problem. And I'm going to do what the book does, and all the books do this. They set you up with clues, kids. They give you clues. Does this factor? Probably does. And look, it's 15. Do you see the 15 on the end? And check it out. There's a 3 and a 5 in play. Do you think this factors into x plus 3 times x minus 5? Could it be that easy? It is. They have set you up. They've given you clues. Look at 3 times negative 5, negative 15, plus 3x minus 5x, negative 2x. It's perfect. It's all set to go. All you got to do is get a common denominator. Now they do a funny thing. Check this out. Negative 48 doesn't need anything because it's got the full denominator. Minus 6 times This guy needs the x minus 5. And it's all over the x plus 3 times the x minus 5. Now, I can multiply this out and see what happens. I'm going to have negative 48 minus 6x plus 30, still all over that denominator. And a funny thing happens, because the negative 6x plus 30 minus 48 turns into negative 6x minus 18, which is negative 6 times x plus 3. There's an x plus 3 hiding up here. When I add these together, it creates an x plus 3. Well, what's the effect of that? Well, it cancels out an x plus 3 over here. I lose the x plus 3. This whole numerator is the same as negative 6 times x plus 3, which means those can cancel. And I have negative 6 over x minus 5 equals 7 over x minus 5. And this is never true. Look at it. What kind of, the denominators are the same. Does negative 6 equal 7? No solution. And here's something I recommend to all of you. I graphed the original left-hand side. I typed all of that in. I graphed this thing, and I hit graph. And here's the picture. I hope you can see it. Well, let's see. Come on. Come on. There we go. The two graphs, the red graph and the black graph, avoid each other. They don't intersect. There's no place where the left-hand side equals the right-hand side. So you write no solution. Now, I could have graphed it first and said no solution. It'd be a lot of typing. But, oh man, I hope you guys are using your calculators. It's so handy. All right, here's another one. Same section. I almost have a common denominator already, because if you guys spot this, you're supposed to know this is w minus 3 times w plus 3. And there's a w plus 3 already over there. So I need a w minus 3 over a w minus 3. And now I'll have a common denominator, which means I can ignore all the denominators if I want to. I just say, okay, w plus 7 is equal to negative w times w is negative w squared. 2w plus 3w is a plus 5w. And then negative 3 times 2 is minus 6. Let's put everything over to the right-hand side. Negative w squared minus w is plus 4w. And then negative 6, take away 7, is minus 13. Well, let's see. That's equal to 0. I'm going to multiply through by negative 1. W squared minus 4w plus 13. And 13 doesn't factor. It's just 13 times 1. This looks like a job for quadratic formula. I'm going to need some space. All right. So I'm going to take this. Here's the original. Take this and hit it with the quadratic formula. So w is equal to negative b, that's 4, plus or minus the square root of b squared, that's 16, minus 4 times 1 times 13. I don't have to do any more. This is 2 times 1 down here. 16 minus 52, that's negative. This is not real. So there's no solution. No solution. They miss each other. I graphed the left-hand side and the right-hand side. And I'll see if I can get this graph to look good for you. Here we go. I graphed the left-hand side and the right-hand side. There you go. Can you see the two colors? The red and the black graphs, again, miss each other. Now, let's do another one. And you say, wait a second, Dan, this is the same problem. No, I changed. It used to be a plus sign. Now it's a minus sign. Now, that's a work saver for you guys, because the common denominator is still w plus 3 times w minus 3. This time, this side needs a w plus 3 in order to have a common denominator with the left-hand side. So this side becomes w plus 7, and that's equal to negative w squared plus 2w minus 3w. So it's minus 1w plus 2 times 3 is 6. I got to get all this W stuff on one side. I think I'll bring it all over here because I want this W squared positive anyway. W squared, add a W over, that's plus 2W. And then I'm subtracting 6, so this becomes a plus 1, which equals 0. This factors. It's got a W and a W and a pair of 1s. Make them both pluses. If W plus 1 equals 0, then W equals -1. We got this. Now let's check it in the original. Remember how nobody checks anymore? We check. We're going to do this check. The original is up here. That's a -1 plus 7 divided by -1 squared is +1, kids. Honest to God. So -1 plus 7 is 6. 1 minus 9 is -8. Now let's put the -1 in just this much. Putting a -1 right there. That's a +1 plus 2 divided by -1 minus 3 is -4. That's a -3/4. And 6/8 with a minus sign on it is the same as -3/4. We win. Now I didn't bother to type in the graphing because I got an answer that was easy to check. But you could have graphed the left-hand side against the right-hand side, and guess where they would have intersected? At x equals -1. That's how it would have worked out. I guess the y would have been -3/4. So anyway, you can tell from a graph a lot of what's going on. So try, please, section 4 and 5. Homework. Section 4, 5. Do some. Do some. Now listen, semester's almost over. This bit where you wait a week to look at things because it's not for a grade yet, you don't have time for that anymore. You got to catch right up, so get to work.